AI, the system which we have, right? Sign language recognition. So basically, we have three different models, mainly models, algorithm model. Okay, one is for A to Z, right? And second one is 0 to 9, and third one model is for words. Okay, so we have these three models in our purpose system. So what exactly primary thing which we have used? Okay, so the primary thing and algorithm which we have used, that is YOLO algorithm. Okay, so now what is YOLO algorithm? Let's discuss. Okay, so YOLO algorithm, if you Google it, YOLO algorithm. Okay, so see, you can get right. YOLO is basically a divide input image into grid and cell, and it predict probability of presence of object. Okay, so it is nothing but in simple term, it is a object detection algorithm. It detect the object as well as classify. Okay, there are two things. Okay, detection means what? Key, suppose this is the image. Okay, so inside this image, the dog area, the boundary box of dog, that particular pixel area is the object, right? So that is detection, and to identify that is dog, that is classification. Okay, so like YOLO is one of the best algorithm for this, for like for object detection. Okay, so in our case, okay, in our case we have to detect the sign language, right? We have to identify the sign language. Okay, suppose this is the image, sample image. Okay, so in the sample image, this is the sign, right? This is the thumb sign. Okay, so this is nothing but an object na. Okay, okay, this is the sign, and she is making the sign, and this is the object we can consider as an object, and we want to detect ki whether the sign has made and what is the sign, right? This is our purpose system, right? So our purpose system is also the same, object detection for the sign language. Okay, so that's why for the object detection, YOLO is one of the best algorithm. Okay, YOLO has recently launched a version, YOLO V8 version. This version, it is basically extremely fast in terms of accuracy, performance, or speed. It is very fast. Okay, uh, see, if you have good laptop performance, no, it will give very fast kind of processing and output. Okay, so YOLO is very kind of as compared to others. There are some others algorithm available like fast. There is a Coco model. There are certain models, I don't remember right now the names, but out of those, YOLO is best for making a model, training the code, etc. Okay, so it has multiple variants. Like YOLO is also have multiple variants. Like YOLO has three different models, like nano, small, medium, large. Okay, these are the models. Like if you search is YOLO V8 models. So here you can see, here is the official repository of YOLO. Okay, if you go down, so here you can see the performance and the models speed. See, these are the models available in YOLO, and these are the accuracies and the speed as per the millisecond. So as you can see, the nano version has very speed as compared to these all parameters. So the speed is very like 18.4 millisecond, right? So basically, we have used YOLO medium model. Why? Because see, this model is fast, but it is not that much accurate, right? This model is bit slow, not that much slow, just having 234 millisecond, not second, millisecond speed for processing a image. Okay, for single image, and it has a good accuracy. Okay, so that's why we have used this one. Okay, so, what exactly YOLO do and how exactly YOLO work? Okay, so let's understand that YOLO V8 architecture. If you search YOLO V8 architecture, na, you will get this image. Okay, so if you open this image, okay, you can read. There are bunch of information and tutorials and explanations available for the YOLO on internet. Just do some research. Ki what is YOLO architecture on YouTube and all. you will give a very good understanding, okay, or explanation. I will just give you the outlines and overviews. Okay, what is YOLO and all, and how we have implemented in our project. Okay, so this is the architecture of YOLO. Okay, so if you look at this image, okay, so mainly you will be able to see this is the complete architecture. Key, what are the layers and neural network YOLO are using? Okay, so but if you see mainly YOLO using convolutional layer, CNN. Okay, so YOLO is built top on CNN, okay, top of CNN algorithm, okay, and they having their detection technique like own technique, and they have implemented for the classification. They have for feature extraction they have used CNN, okay. So mainly, what is CNN algorithm? CNN is our base layer, okay, or base algorithm for every deep learning architecture. So what is CNN layer? Okay. So basically, what exactly CNN algorithm do, convolutional layer algorithm do? See, this is the general architecture of a CNN layer. Okay. So you have to explain in the college key what is YOLO, what architecture it is using, what neural network and what layers it is using. Okay, and what is the use of convolutional layer and all. Okay, you have to prepare your presentation, and you have to do the practice, and you have to do more research for this. Okay, so this is the architecture. Okay, so what exactly YOLO do? Yeah, CNN algorithm do. Okay, let's suppose this is the input image of zebra, right? So how I have identified that this is zebra? Okay, based on the uh, the shape, right? Based on shape, I have identified. Second thing is based on the color pattern. Ki zebra has white and black pattern of his skin, right? And it has a tail and it has some hair, right? So based on this, I have identified, right? So these are nothing but a features. Ki I have identified ki zebra has four leg, zebra has tail, zebra has black and white color combination. These are the features, right? So in general, brain is also work on just like a neural network. Okay, basically network is derived from brain architecture only. Okay, our real brain. Okay, so CNN algorithm do the same. Okay, CNN algorithm help to identify such features ki, so that algorithm can able to identify or uniquely define that label or image ki this is the zebra. Okay, so this is the zebra. So internally, CNN layer used to identify such features from the input image कि so that they can identify कि this is the zebra कि whatever उसका फीचर रहेगा कि उसके बेस पे वो आइडेंटिफाई कर पाए कि दैट इज जेब्रा. So that is the mainly work of CNN. Okay, it create a feature maps. Okay, based on convolutional ReLU network, it creates a future map. Okay, so basically see this is the input image, but here you will be see if you Google more, do more Google. mm, yeah. So basically, see, whatever feature will be generated, that will be generated in form of this matrix. Okay. Why this matrix? See, this is the image, right? If I zoom this image, okay, so you will be able to see a boxes kind of pattern, right? I'm clicking anywhere, so it is creating a box. Okay. I have zoomed almost 100%. That's why I am able to see these pixels. Okay, so this box is nothing but a pixel. So this is called pixel. So every image is collection of pixels, right? Depending on resolution. Depending on resolution, it collection of pixels. And a pixel is nothing but a RGB value. Okay. See, if I zoom to normal, so you won't be able to see that. You will be able to see a proper zebra image. But if you zoom it, okay, in big level, you will be able to see the dots, right? So these dots, this dot, whatever the dot is nothing but RGB. RGB means what? Red, green, blue. So every pixel is considered the value of R, red and green and blue, the color value. And if suppose R value is 20, G value is 30, blue value is 40, right? So if I replace this pixel with this value, so this will become a matrix, right? So if I replace every pixel with these values, so this will become a very big matrix, right? So internally image is also nothing but a matrix or a numpy array in the our system or a CPU or in a hard drive. So that is stored in the form of numpy array only. We will be able to see the image kind of view just because it decode and give the output. Okay, but internally it has the numbers. So that is also same because algorithm required numbers data only, numpy data or array data. So that is only able to understand it. It don't understand label, image, text, etc. Okay, it just understand the arrays format. So so we do the same. First we convert the image into array, and then array will be get passed to this convolutional layer, and then convolutional layer will identify the such matrix pattern from the input array. It will identify a different based on the layers structure. It identify the matrix. Okay, so that is the main use of this CNN. Okay, so so you have to do some research ki what is YOLO architecture and all. So and you will get it. Okay, this is the architecture. I can't explain each and every block because even I don't know every block information. Okay, so you have to do YouTube. You will be get it. Okay, key. But I don't think you have to explain complete only. You just have to explain in college that you have used YOLO algorithm and it has neural network architecture and it is mainly built on top of CNN. And CNN, what is the use of CNN? I have told you. So you have to explain accordingly. Okay. So now, so this is about the algorithm part. Okay. So now let's understand ki how exactly we have trained the model to detect such gestures or alphabets or numbers. Okay. So I have given you the folders, right? The project folder. So in this, I have given you one notebook folder. So you have to go inside this notebook folder. If you go inside this notebook folder, now you will be able to see the codes. Okay, just like this is for a gesture, this is for A to Z, this is for number. Okay, so if you open any of these, let me open the gesture one. Okay, so you will be able to see the complete code for the YOLO key, how we have trained. Okay, so first of all, we have used Colab, Google Colab, Google Colab for training algorithm. Okay, so why Google Colab? Obviously, Google Colab gives us free GPU, and we can upload a data set and we can let it be trained because see, YOLO algorithm takes time to train the model. It took depending on data set, it takes the time like 4 hour, 5 hour, right? So we can't keep our laptop doing the processing for the training, right? So it will gets effect, right? So that's why we are using this Google Colab. We have just uploaded a data set into our drive and we have connected. Okay, we can directly connect the Google Drive in our notebook. Okay, so here is the code. Okay, for the same, and you will be also able to see there is a data set link. I have also provided you data set link for the every uh, data set. Okay, you just have to go there. Okay, so basically, morally we have identified this dataset from RoboFlow. Okay, so if you search RoboFlow, RoboFlow is basically one of the best or perfect platform for the dataset finding, for the detection, object detection perspective. Okay, so here you will be able to see lots of dataset. If I search key sign language dataset robo flow. Okay, you will get a huge bunch of data set for the thing. Okay, so based out of this, I have identified the best data set and I have downloaded and uploaded on Drive, and I have shared you the link as well, right? Every link for the data set. Okay, so in the data set, we have basically three different part like training, t- testing, validation, training. You will also able if you want a real link, exact link. So you just have to go open the RoboFlow files. This is a dataset file, and you will be able to find it from here as well. Okay, so this is the real link of dataset. Okay, so if you go there, so RoboFlow, we can see this is a data set. So this data set we have created. Okay, so this is our own data set. So these are the images. Okay, so in RoboFlow you can also do the labeling. You can upload a image. You can create a project. You can upload a image, and you can create a boundary boxes. See, these boundary boxes means we are telling algorithm key this is the object which we want to detect and what is the object name. We are just identifying. Okay, if you upload an image by your own RoboFlow account, na, you will be able to see get the uh, get the option to draw the box. Okay, let me go to my project and let me show you. See, these are my some projects. Okay, so these are the images. So these are the images. Okay, suppose this is the data set. So if I click, suppose I want to add some annotation, right? So I can add it. Where is the option here? Yeah, okay. So here is the option to create a boundary box. Okay, so like that I can create the area where I want to detect, and I can also do the labeling. Okay, this way we have done for these all images. Okay, and then we have downloaded this data set, and if we download the labels mean this boundary box and information along with the image like this. If you go there, see there are three part: training, testing, and validation. With the training, we will be do the training of a model algorithm, and with the testing, we'll do the testing. Okay, so in the label, it consists all the labels key XYZ coordinate of that box, that particular box, and it store also the class type key, what is the class key, whether it is 0 1 etc. Okay, like that. Okay, and in image, it store the images. Okay, so now let's go back to the code. Okay, so see here what we are doing, we are downloading the data set, then we are connecting the Google Drive, and then we are whatever data set we have downloaded, we are unzipping the data set, and then we are downloading some libraries. Okay, so basically see YOLO also provide their own library Ultralytics. It called Ultralytics. Okay, before YOLO V5, V4, V3, we have to download the repository and we have to do a lots of configuration. Okay, but after V7 or V8, V8 is latest one. Okay, so after V8, it has given our given the library, and we can directly install and use. Okay, so we just have to download this library. Okay, and then we can do the training of algorithm like this. Okay, we have to pass the YOLO command. This is a command for training the model. Okay, so here you can see we our task is to detect, right. Our mode is training. Our model, like I told you, the model, right, key nano, small, and fast. So we have used large one to get the more accuracy, and the image size, and the data set path, and number of epoch. Epochs means ki number of times algorithm will do the training, do the understanding depending on data set. Ki suppose you are reading a book for first time, how much percentage you will understood? Only 10 20%, right? But what if you read the book second time, you will understood 50%, right? If you read the third time, you will understood 70%. As much you read the book, you will get the more understanding, right? So we have made 100 epochs to do the training 100 times. Okay, and then we have defined the batch size and the output folder key where we have to store the result. Okay, and after that YOLO will load all libraries, all images. Okay, and it will do the training. Okay, so these are the training data key. We have done 100 epochs. So at 100 epochs we will be getting the final accuracy. So this is the 100 epochs, and then finally where is the remaining epochs here? Okay, so here is the final all. Okay, so almost recall factor, precision. Okay, we have almost got more than 90% accuracy. Okay, on the data set. Okay, so basically what data set ki, basically we have separated the data set, right? So after training we just pass the data set and get the accuracy. Okay, and these are the some architecture, and I have also plotted the graphs. Okay, so 92% accuracy we have achieved. Okay, recall factor, confidence. Do some research. What is F1 score? What is confidence? What is recall? What is precision in YOLO? You will get more information. Technical formula. You will get it. What is technical formula? Mathematical formula. Just like this. Just search it. What is formula of precision? You will get all information. Okay, so from there you will be able to get the formulas and walls. Okay, so this way you have done. Okay, so I have shared you link as well, right? The dataset link. So in the dataset link in the training, okay, suppose you want to get the confusion maps, correlation matrix, result, CSV, all graphs. So all graphs are available here. Okay, so you can put this result, this confusion matrix in your thesis and all, or if you want to present in faculty, you can present from here. Okay, so these are the all graphs combination combining of all graphs. Okay, so it internally YOLO creates. Okay, and here you can also show the some test result. Okay, batches. Okay, so this way we generally do the training. Okay, if you see the code, we have do the same thing for number detection, for A to Z, or for words. Okay, each and every uh, model we have used the YOLO V8 architecture. Okay, so this way we have done the this training of sign language. Okay, and this way YOLO is capable of detecting the same. So now let's go to the code. I suggest install VS Code, Visual Studio Code. Okay, and then go to file, then go to open folder, and then go to your project folder. Suppose this is my project folder, and go to open and then select folder. Okay, like this. Okay, and I also suggest uh, just before demo. Okay, before going to demo or all, just run the project and just try to create these gestures and do different testing with the project. Okay, so that you will be understand ki how we have to create the gesture, so that algorithm will predict. Okay, because that is very important. If you make correct gesture, then only it will predict, otherwise not. Okay, i refer I refer suggest this image. Okay, this is the perfect image. Okay, perfect means with this gesture pattern, algorithm system is predicting more accurately. Okay, it is not getting open. Okay, I don't know. This is not that perfect gestures photo. This one is the perfect. Okay, so if you make this gesture, the system will understand. I have given you demo as well, right? So with it in the demo, you can see. So just you have to follow the same. So now let's go back to the code. So if you go to the code, so there are bunch of files are there, right? Web main UI support, login, image module, etc. etc. We have not used the image module. Okay, that is not useful. Okay, so see, for building the UI front end, okay, for building the front end buttons and all, okay. So what we have used, okay. So in Python, to for building a front end, basically there is a tool uh, called Page Builder. So Page Builder is a tool. With this tool, we can create a front end by drag and drop functionality. Okay. Suppose I want to create a label, so I can click to label and then I can click here, place here. Suppose I want to click list box. Okay. So like that, I can choose a widget and I can create the UI. Okay, and I can also assign the labels and buttons. Okay, so that I can perform the operation. So this way we have created a user interface using Page Builder. Okay, you can also download from Google Page Builder software for Python. Okay, and suppose now I want to generate the code, so you just have to click generate Python GUI, and you just have to save the file, and then you will be able to see the Python code like this, and then you can just copy the code and you can paste into your project and you can run. Okay, so this is the same we have done for the login page or home page or remaining pages. Okay, so here you can see this is a similar kind of code. Okay, just the only thing we have done, we have binded the click function. Like if you click to login button. Okay, so we have created a function, login button function, that we have binded like this is the right button of mouse. So when we click, so this function will get called. Okay, like that. So this way we have done the UI part and the uh, remaining UI operations. Okay, so yeah, so this way we have done. See, code, you will be able to see the similar code because that is getting generated from the tool, right?
This is the complete project. If you're in doubt, then you can comment in the comment section. I will try to reply soon. And thank you friends for watching my video. If you're new, then subscribe channel and share with your friend. Thank you.